In this video, we conclude our discussion of salt solutions by talking about how we would go about calculating the pH of a salt solution. So to determine if a salt solution is going to have a pH other than 7, first we want to check to see if our salt undergoes hydrolysis. The hydrolysis reaction generates either hydronium or hydroxide. That is going to be the one used in order to determine our pH. So the hydrolysis equation that generates either hydronium or hydroxide is used to set up an ice table. And with that ice table, we determine our equilibrium concentration. So just like with our straightforward acids and bases, our pH is dependent on equilibrium concentrations. So we've got a solution of 0.250 molar KOCl. And ultimately, we're going to walk through several steps, but ultimately our goal is going to be to determine the pH of this solution. So we need to know, first of all, is our solution an acid, base, or now we add, is it a salt? So I'm looking here, I don't have hydrogen, I don't have hydroxide, I don't have nitrogen. That's going to tell me this is not an acid or a base. I've got a metal cation with a polyatomic anion. This is a salt. So the first thing we're asked to do is write the equation for the dissociation of this salt. So if I take KOCl and I put it into water, we're going to produce potassium cations and OCl, so hypochlorite anions. So then we want to check if this undergoes hydrolysis. So if I look at my K+, this K+ would have come from potassium hydroxide, which is a strong base. So that means this K+ is the conjugate acid of a strong base, which means it's weak, no hydrolysis. So with my potassium, we get no reaction. So look at my OCl minus. My OCl minus would come from HOCl. And HOCl is not one of my 6 strong acids. So this is the conjugate base of a weak acid, which means it's strong enough to undergo hydrolysis. So as a conjugate base, it's taking a hydrogen from water. So it's going to form HOCl and hydroxide. Now, so my base is going to be a basic salt. Because that OCl minus is the conjugate base of a weak acid, it undergoes hydrolysis, it produces hydroxide. Now, the pH is going to be dependent on this hydrolysis reaction, and it's an equilibrium, and our equilibrium is expressed by a K. Since this is a base, this is represented by a Kb. And we can set up our Kb expression. So that would be the concentration of HOCl times the concentration of OH minus divided by the concentration of OCl minus. Now, we've got to be careful here. We've got to pay attention to what we're provided with in the problem. And we were given Ka. This is the Ka for the parent acid. And again, this is not uncommon. So when we're looking at tables and books, we've got limited space. We can't put everything there. We're going to list the more common materials, and generally you're going to list your parent acid or your parent base. But we have a relationship between the K for an acid and the Kb for its conjugate base. They're related by the following equation. We have that Ka times Kb equals Kw. So we can use this to determine the Kb for the conjugate base. So my Kb, if we rearrange that equation, is going to be Kw divided by Ka. So Kw is 1 times 10 to the negative 14th. Ka is 3.5 times 10 to the negative 8th. So that's giving me a Kb of 2.9 times 10 to the negative 7th. Now again, we said our goal is going to be to determine pH, which means we're going to need equilibrium concentrations. So the next part of our problem is asking us to set up an ice table to determine the equilibrium concentrations of all species present. So I'm going to set up my ICE. My salt, we need to know the concentration of the OCl minus. This is one of the reasons we want to go ahead and dissociate that salt so we can see the ratio. We've got KOCl starting at 0.25 molar. When it dissociates, I get a 1-to-1 ratio. So 0.25 molar potassium, 0.25 molar OCl minus. So that's my initial concentration of my OCl minus. We don't care about our water. Our products are initially 0. My reactant goes down by X. My products go up by X. So at equilibrium, I've got 0.25 minus X for my OCl minus, X for my HOCl, X for my hydroxide. So we plug that equilibrium line into our K expression. So once we get here, this is just like finding the pH for an acid or a base. The difference is we're just starting with a conjugate acid or a conjugate base. So we plug this into our K expression, and we're going to get X squared divided by 0.250 minus X equals Kb. So this is where we've got to pay attention. Understand that we've got a base that we have to work with a Kb. This will be common for your salts. You're going to have to convert and make sure you set it equal to the right thing. So it's set equal to 2.9 times 10 to the negative 7th. I have a small k. So we would check X negligibility, and we were going to find that it is. So my minus X goes away. I have X squared over 0.25 equals 2.9 times 10 to the negative 7th. So we're rearranging and solving for X. And we're going to get that our X is 2.7 times 10 to the negative 4th. So we would plug that back into our ice table to get our concentration. So my hydroxide is 2.7 times 10 to the negative 4th molar. My HOCl is 2.7 times 10 to the negative 4th molar. And then my OCl minus, we round back to our significant figures, and we're still left with 0.250. So our final question asks us for the pH. Again, we've got to pay attention to what we have. At this point in time, we have the concentration of hydroxide at equilibrium. So we've got to work from there. Now, if I have a hydroxide concentration, I can determine my pOH. And so my pOH is going to be equal to 3.57. My pH is going to be 14 minus that. So I'm going to have a pH of 10.43. We've identified our salt as being basic. We expect to get a basic pH. If you don't, that's your key to double check your work. With these problems, usually there's 2 mistakes. One is not converting the K to the K that we need, or just taking the negative log once you get X. You've got to pay attention to what you have. We have a basic salt here. So we've got hydroxide at equilibrium. If we take the negative log, we're getting the pOH. We've got to convert pOH to pH. So your next problem, number 5, parts A and B. That will give you guys some practice with calculating pHs for salt solutions. I encourage you to work on those problems, and there is a detailed answer key to those on Blackboard.